Okay, I'm going to try to reason through this problem first before actually writing anything up as a proof. What you're given in this problem is you're given this bizarre looking picture, which is a straight line on the bottom. So there I have this straight line here on the bottom, and I have all these segments going out of this angle. This is just given to you as the first diagram. And the information you're given in the problem and what you're trying to prove, let's just dissect all that apart. Let's actually, instead of what we usually do is we really think about the given, let's look at what you're trying to prove first so it's very clear. If you look at the proof statement, you're trying to prove that angle JBC, which is this angle J, the middle of the vertex is the B, as I mentioned before, and then this angle here. This angle here is equal to angle FCB. That's this angle right here, FCB. You're trying to prove this angle over here is equal to this angle over here. So that's what's shaded here. You're trying to show that these two angles are the same. That's your goal. Okay, so now I'm defacing this, but let's look at the information that's given to me one by one. The first piece of information that I'm given is that BJ and BK trisect angle ABH. So that means that this guy here and this guy here divide up this angle, and I'm going to see if I can use a different color, this angle here into 3 equal parts. So all these parts are going to be the same on this side. And the second thing that's given to you is that, I'm going to use a different color here. You're also given that CE and CF trisect angle DCG. So angle DCG is this one right here. That means this guy over here and this guy over here cut up this angle, and I'm going to put that one in red again. This angle here is cut up in 3 equal pieces. So these 3 guys are all the same. I'm defacing this a lot, but I hope you're tracking what's going on. Finally, the last piece of information that I'm given is I'm given that angle ABH is equal to angle DCG. Those are the 2 red angles. They're both the same. So this side here, this angle measurement and this angle measurement in red are both the same. If they're both the same, the first observation is that if I cut the left side into 3 equal pieces and I cut the right side into 3 equal pieces, that means each one of these small pieces, this one, this measurement, this angle, this angle, and this angle have to be the same as all 3 of these. They're all equal sized angles on the left and right. That's the first observation. So what happened here in this picture is instead of waving a mouse around, your teacher wanted to actually number all the angles so that she can talk about them. And I'm going to use her numbering so that we stay on the same page. So she numbered all of them. Let me start with somehow these numbering. I think what happened is she was doing certain thoughts in a certain order. And so she labeled this one as angle 5. She labeled this one as angle 4, labeled this one as angle 3, labeled this one as angle 1. And then she labeled this angle as angle 2. this angle as 6, this angle as 1, or 7, so that's a 7, and this angle is an 8. So they're just labels so that I can keep track of what I'm talking about. So instead of waving my mouse around, I can tell you that the measurement of angle 3, 4, and 5 are exactly the same as the measurement of angle 6, 7, and 8. So that's the first observation. Well, if you look at the piece that I'm supposed to prove, that this blue angle JBC is equal to the same angle BCF, the blue parts, the two angles that I've listed, I already have that angle number 3 and angle number 6 have to be the same measurement because they're part of the trisection. The left side is exactly identical to the right side. So this 3 part here, and I'm going to see if I can use a color here to explain it. I'm running out of colors. Let's see. I'm just going to shade it. So this is why she started shading things. This part here has to be the same as this part here because they were all trisected. They're identical. So all I'm left really is this remaining piece, number 1 and 2. If I can show that number 1 and 2 are both equal in measurement, I have that this whole angle, that this part here, this part's the only part that's missing. And if I can show that these two things are the same, oh, I don't know why that disappeared. There we go. That this thing here is the same thing as that other shaded blue, I'm done. That's really what I need to show. So it all boils down to 1 being equal to 2. Let me put the 2 outside here so you can see it. There's the 2. I really need to show that. How do I do that? Well, the way you do that is I'm going to now pull out this picture. So here's the left side. This is I'm just going to pull out part of the picture so you can see it. ABH, G, and I'm this C. Oh, I'm going to draw the C. Well, C, D, like this. And this. Well, it turns out that this part here, and this was D, so I didn't put all the letters and all the things. I know that this part and this part, and I put this red, the red plus the blue, this red angle plus this blue angle are what we call a linear pair. They're supplementary. They add up to 180. And I know that this part here, the blue parts are both the same. This blue part's the same because that was given to me. They told me that those two angles were the same. So if I have really that, what that means is since they add up to the same thing, the whole thing is 180. The blue parts are equal to each other. The red parts are 180 minus the blue parts. The red parts must be equal to each other too. So once I have that red part is equal to it too, then I have the whole thing because the red part's really down here, red in my other diagram. So that's how I reason out the second part. I need to use the fact that they're linear pairs, and if I have the blue part down here are equal, and the total thing totals up to 180, I think I'd like to use letters to explain this. So let me pull this over to another page so I can explain this one more time, because this is confusing. There's a lot going on in this. Let's see. there's my picture back again. If I look at this picture, let's suppose I didn't know those red pieces were equal. I'm really trying to prove those red pieces are equal. So I'm going to call this piece here X and this piece Y. I don't know that they're equal. But I do know that this part here, which I'm going to call Z and W, oof, my hand. I'm going to call this one Z and I'm going to call this one W. I know that Z and W are equal. And I know that Z plus X has to be 180 degrees. And I know that W plus Y has to be 180 degrees. Well, since W and Z are equal, I can substitute the W for Z, and I get that. If I just eliminate the 180 and just don't worry about it, I get Z plus X is really Z plus Y, and these guys cancel, and I'm left with X is equal to Y. So that's the reason, it's because they're supplementary angles. That's the reason the X and the Y are the same thing. The two red shaded regions are the same thing. That's the proof in words. If you're going to do left and right columns, you have to go back to the beginning one by one and justify it. So let's do the proof left and right. And let's get that awful picture back. Not that one, but this one. In fact, what I'm going to do is I'm going to make the picture again, and then I'm going to make it not defaced. I'm just going to label everything. Now that I understand, at least I understand what's going on, it's a lot going on here. I have the A, the B, the C, the D, and then I have this trapezoid in between, and then I have this was trisected, and then I have this was H, and this was G up here, and this was K, and this was J up here, and this was F, and this was E right here. And I'm given a whole bunch of stuff, but I start my reasoning now, okay? So, and I'm going to label them the same number she has. This is 5, 4, 3, and this is 1 over here, and this is 2, 6, 1, 8. And in terms of her numbers, what you're trying to show is that I'm trying to show, I forgot a word here. I'm trying to show angle 3 plus the measure of angle 3 plus the measure of angle 1 is the same thing as the measure of angle 6 plus the measure of angle 2. That's what I'm trying to show. All right, so two-column proof. I'm not sure what given means. But the first observation I'm going to have, maybe you're supposed to start with given. I don't write proofs that way, but in school we don't, in graduate school we don't write that way. But let's just start with number 1. Angle 5, measure of angle 5 is equal to the measure of angle 4 is equal to the measure of angle 3, which is also equal to the measure of angle 6, which is equal to the measure of angle 1, is equal to the measure of angle 8. Left column, that's my, I don't want to like split my reasonings out. So right column, statement. Let me do it this way. Can't see what I have here. So I'm going to go statement. I need space to write. And my reason for 1 is given that measure of angle ABH is equal to the measure of angle FCD, and measure of angle 5, let's see. Here's how I want to say it. And angle 5, angle 4, angle 3 trisect angle ABC or ABH, and angle 1, angle 6, angle 8 trisects angle at GCD. Definition of trisects. All right, so that's my first reasoning. I would want to say more than that. I would want to say, so therefore, one piece of this, the important piece of this is not all this information. The important piece of this is that angle 3 is equal to measure of angle 6. Okay, the second thing. Let's take the picture with us. And go to the next page. There's that picture. I'm going to move that picture a little bit. Okay, there we go. Okay, so now I have measure of angle 3 is equal to the measure of angle 6. Now I can say that measure of angle 1 plus measure of angle 5 plus measure of angle 4 plus measure of angle 3 is equal to the measure of angle 2 plus the measure. So statement is this. By let me just put an unnecessary piece of information, but this is where I'm getting this from, is equal to 180 degrees. And to reason would be angle 1 and angle 3, angle 4, and angle 5 are linear pairs and therefore supplementary. And same for angle 2 and all the rest. Same thing. So the next step is you can conclude that angle 1 is equal to angle 2. Statement. Reason is, I'm not going to write that again. I'm going to actually take this, it's algebra. If I take this guy here and copy it and then paste it to the next page, because this is true, and the bracketed parts, which some of it is underneath my pens, and bracketed part is equal by given. They told me those two angles, the sum of them is going to be like, that's the big angles. Because that's true, I can cancel that from both sides. This O is not supposed to be here. Because that's true, I can throw the bracketed parts off. They're canceled from both sides. And I'm left with this. I should put measure here. Got to be exact. All right, concluding statement. My last statement is step 4. Statement is that I need my picture. Let me go to another page because it's just too much without the picture. I want to go to this one. Remember, actually, let me go back to the very first picture. Remember that I was trying to show this part here. Let me pull this. Copy this. And then move to the last page. Remember, I was trying to show that this whole angle here, and I'm going to recolor it, this whole thing here was equal to this whole thing here. I just got done showing that angle 2 and 1 are the same. And I was given that 3 and 6 are the same because it was part of the trisection. So my last statement is 4. Angle JBC is congruent to angle, oh, I forgot this G up here. I think this was a G. Let me double check. Yeah, it was a G. Is congruent to angle GCD. Why? Sorry, not GCD. I got these wrong. JBC is congruent to FCB, sorry. So FCB was, I forgot to label all these because they fell off my picture. Here's my F and here's my E. So I got, the blue part is FCB. So they're congruent. Why? For a reason. Because measure of angle 3 plus measure of angle 1 is equal to, sorry, I'm not used to writing all these angles. Is equal to the measure of angle JBC. and measure of angle 3 plus measure of angle 1 is really the same thing as measure of angle 6 plus measure of angle 2. Showed it in pieces by earlier steps. I forgot the numbers. And measure of angle 6 plus measure of angle 2 is equal to measure of angle FCB. By definition of congruence, I don't need measure. Those two things are the same. No more measures needed. It's just a long problem and you have to hold your thoughts together. So that's what makes this hard. I hope it's clear. I hope you have to kind of think this one through. Let me pull this up and before you even get started. So I'm going to ask you some questions about this to make sure you understood it. And I'm going to cross fingers you did. I'm not going to do the other one. I think doing one of these is enough to kind of know like how complicated it gets. And if you want me to do the other one, I will.